Dear student, I am Santhan, working as a physics faculty in Target English Medium School. In our previous video, in the chapter of motion, I explained some of the think and discuss question from our motion chapter, from the motion chapter. Now, in this part video also, the remaining think and discuss we are discussed. So these think and discuss questions are very important. These questions are represented application oriented question based on the particular topics. That's why you can watch these videos 3 or 4 times carefully after checking the question with reference of our textbook. Okay, so let me come to the next think and discuss. Okay, in this chapter, a speedometer of the car indicates a constant reading. So, the car is in uniform motion or not? Listen very carefully. Okay, so we already discussed that in the vehicles. What is there? A speedometer is there. Means speedometer means one instrument is there in that one speedometer and one odometer is there. Now our concept, what is that one means? The speedometer in a car is showing a constant reading. Okay, is the car is in uniform motion or not? That is the first one. Okay, so that's why listen very carefully. In a speedometer, it is the speedometer. In this one, it is a odometer. This is the speedometer. In the speedometer, we have 0. It is the 140. Just let me say that. Okay. It is the 90. Like this one, I can say that. 100. Like this one is there. So, what is our question means? A car speedometer. A car. Okay. Speedometer is showing a constant reading. Constant reading means, for example, it is showing means it is either digital or analog. Okay, in the analog, the needle is showing 90 degrees, just you can 90 angle. Sorry, it is showing the 90 numerical, or in the digital, it is displays the 90. What is the meaning of that one? Means the car is moving 90 km per hour. That is the meaning. Means so entire his journey from particular place according to the statement I will says that. Okay, a car speedometer is showing the constant reading is nothing but up to particular distance of the journey. So the car speedometer is showing only constant, means from starting to ending within the short period of time, whatever that may be. What is the value? For example, 90 kilometers per hour. Or 80 or 100, whatever that may be. But for understanding of it, I will consider one value, that is 90 kilometers per hour. Okay, means it's nothing but here. Okay, a person is starting from point A and he moves towards the point B. That's why here. Okay, in this one, so the car is moving from point A to point B. Okay, so to reach the point B from the point A, it takes certain time. But whatever the time, we don't consider. But from A to B, for entire the journey of the car, okay, the car is moving how much speed? 90 kilometers per hour, constant speed only. At that time, the car is in the uniform motion or not? That is the meaning of that. So already I clearly says that under the kinds or types of speed. So what I say is that if a body covers equal distances in equal intervals of time, however the time intervals are maybe small, the body is said to be in uniform speed or uniform motion. Is nothing but when a body is moved with constant speed or uniform speed, at the time the body is in the uniform motion. That's why here the body is in which motion? Uniform motion. Because of when the body is moving with a constant reading is nothing but the speed of the car is constant. That's why when the speed of the car is constant, means it is moving with a uniform speed. Next one ant is there. The ant is moving on the surface of a small. Okay, so listen. One ant is there. An ant is moving on the spherical ball. Does its velocity is same or not? That is the question. So listen very carefully. It is a spherical ball. So what is the question for us means? Okay. An ant is moving. An ant is moving on the surface of. Listen. An ant is moving on the surface of a spherical ball. Is the velocity of the ant is changes or not explained? In this one, I will explain in the two modes. Okay. First one is, but here in the question they are not given clearly. But the ant is, for example, without dying. Most probably, ant is moving means without dying. Okay, without dying, so it will be travel means you know that some beetle nuts are there, beetle worms. The beetle worms you are observing that. Okay, so one type of their prey is there. In that prey, you are observing that. Okay, they are continuously rolling. But in this one, only the ball is rolling, but not the which one? Okay, so beetle nut. That's why, like the same way, here is also an ant is moving on the surface of the rotating ball. In this one, the ball direction is like this one. It is moving in the clockwise direction, in the rotatory motion. Okay, it is moving like this direction. But in this one, if for example the ant is moving along the what is that one? Ball from its surface, then what will be happen? The ant will be after comes to here. Okay, this spot slowly comes to here and it will be touches to the ground again, come upward. That's why automatically the ant is died. But here we are not considered the ant is dead, still it is alive and it is moving on the surface of the ball. At that time, what you are considering means the ant is without moving. What it will do? It will be fastly push the ball to the back. Is it correct or not? Otherwise, what will happen? It is slippery and the ant is moving along with this one and it will be dead. That's why. So we are observing that the position of the ant is in the same position, but the ball only will be rotating. So it is nothing but what you are observing that in this one it is the point A, point B, point C, point D. Now, initially, at any one instant time, the ant is moving on the surface of the metallic ball at point A. Now, okay, so the ball is in the which motion? Rotatory motion in the clockwise direction. That's why the A is comes to the point B. B comes to C. C comes to D. D comes to A because of it is in the rotatory motion. Like this one, for example, AC we can say that. Okay, A is comes to B, means C is D. A is comes to C. C comes to A. That's why. So when in the rotatory motion in the clockwise direction or anti-clockwise, but here according to clockwise direction in the rotatory motion. That's why point A of the surface of that one will comes to the point C, or means direction is continuously changes. When at point A means at point A, what is the direction? Means here totally 4 points were considered, or 4 particles are okay. 4 particles were considered in a ball. Okay, we consider any one ball A ball. At any instant time, the position of the A particle at A, what is the direction? East. After some time, it comes to the point B. What is the direction? South. At C, west. At D, north. That's why already I say that when a body is moved in a uniform circular motion, its speed is constant but velocity is not constant because of directions or changes. Here is also, if totally 4 particles we are considered on the rotatory motion of a ball. In this one, you consider either A, any one of the point. I will consider the particle A. Particle A at instant time it is in the east side direction, but due to in the rotatory motion, the particle is not constant on this position. This particle is comes to the B. When this particle comes to the B, means P particle. If the P particle is comes to the B position, what is the direction? South. If the same P particle comes to the point C, what is the direction? West. If the same P particle comes to the point B, what is the direction? North. That's why you are observing that here, okay, the position of the particle is, okay, not constant. If the position is changes, okay, and direction is also changes are not here, okay, that's why simply we are says that the ball is, for example, moving with the same speed, we have considered that, but direction of the particle is not a constant. That's why here we say that the ball or the metallic sphere is in, okay, the metallic sphere is moving with a constant speed but not in the constant velocity. But that is not our answer. Whatever, that is not our topic. What about the ant velocity? So means ant is always on the which point? A position only. Means particle P is initial at A, next B, C, D like this one. But what is the position of the ant? At the same A point only is there. That's why what is the direction of the ant? Only one direction. That's why you can say that the ant is moving with, means what is our question? Or, okay, is the ant velocity is changes or not? Means the velocity of the ant is not changes. That is we discussed that. If the velocity of the ant is changes, what will happen? Velocity changes is nothing but the direction is changes. If the direction of the ant is changes, if it will comes to here, it will be fall down. Then this ball will be moving onto the ant, then ant is dead, it is not alive. If the ant is alive still means it must be on which position? Point A position by applying a large force in the backward direction of the motion of a body. That's why the ant's velocity is constant. Listen very carefully. An ant is moving on the spherical surface of a rotating ball. At this time, the rotating ball direction is continuously changes. That's why in case of the ball, speed is constant but the velocity is changes. But in case of ant, the ant position is does not changes from its initial position. That's why the direction of the ant moving on the ball is constant or only one direction. That's why velocity is does not changes. Which one? Ant velocity is does not change because of the ant direction of the ant is only one direction at that point. Next, third one. So give one example. Give one example of motion where there is a change only in speed but no change in direction of motion. Listen very carefully. Give one example for changing the speed but not changing in the direction. Question number 3 I answered that. So you can tell or give one example in which cases speed of the body is changes but not the direction. Speed is nothing but we know that it is a scalar quantity. Scalar quantity means it has only magnitude. That's why for first thing, one thing I say is that the simple best example, a freely falling body. So we know that when a body is moving vertically downward here, at point A, what is the initial velocity? 0, because of now the body is in the rest at h height from the ground. When the ball is released, when the body is releasing from your hand, it will move vertically downward due to the earth gravitational force. And I say that for every 1 second, how much speed is increases? 9.8. That's why in the first 1 second, 9.8. In the next one, 19.6. Like this one. Means you are observing that here. So initial speed is 0. In the next position, 9.8. In the next position, 19.6. Here you are observing that the speed of the body is gradually changes. But what is the direction of the body? Only downward direction. That's why this is the best example to understanding the, okay. So the speed of a body is changes, but there is no change in the direction. In which cases? In a freely falling body. Like the same concept also discussing that. Okay. Like this one. Okay. So A to C, a body of, okay, a body is starting from point A, it is moving towards the point C. Okay, that's why A to C means in which direction? East side direction. That's why. So when during in the motion, the body is moved with variable speed. Means, okay, simply you can say that when a body is moving, sorry, if a body covers unequal distances, are understanding or not? If a body is covers unequal distances in equal intervals of time, okay, so in a specified direction, then the speed is constant. Sorry, the speed is changes, but the velocity is constant. Sorry, speed is changes, but the direction is constant or same. Is it correct or not? So means simply here says that. Okay. So means when a body covers unequal distances means the body is not moving with a constant speed, it is moving with changes or variable speed. That's why if a body covers unequal distances in equal intervals of time in a specified or particular direction, during that condition speed is changes but the direction is not changes. Okay, so that's why these two are the best examples for which one speed is changes but direction is not changes. So next one, question number 4. In the think and discuss. What is the acceleration of, listen very carefully, what is the acceleration of a race car? It is moving with a constant velocity 300 kilometers per hour. Listen very carefully. So you can, what is the acceleration of a car? We can find which one? Acceleration. They are given velocity. So V is equals to 300 kilometers per hour. That is equals to 300 kilometers per hour. You can write anyone. So it is which velocity? Constant velocity. Okay. What is mean by acceleration? Acceleration is nothing but the rate of change of velocity is called acceleration. Listen very carefully. The rate of change of velocity is called acceleration. Okay. So, but here means if the velocity is changes, that is called acceleration. But here what they are given that the race car is moving with which one? Constant velocity. Constant velocity means the velocity of a body during its journey is does not changes. Is nothing but here. Okay. A race car is starting at point A. So its initial velocity is u. Are understanding or not? Initial velocity is u. So that's why u is equals to what is it one? 300 kilometers per hour. After certain time also, okay, the car is at point B. Its velocity is 300 kilometers per hour. Means what is the meaning of that one? We are observing that a car is moving with constant velocity. Constant velocity means the body covers equal distances in equal intervals of time in a specified direction. When a body is covers equal distance, equal intervals of time, if the body moves with a constant speed, that's right. So what is the initial 300? What is the next one? 300 means the velocity is does not change accordingly because of the car is moving with a constant velocity. So if the velocity is not changes, what about the acceleration? It is zero. Means the car is moving with zero acceleration. Means nothing but A is equals to, we know the formula, V minus U by T. Okay, what is the T? Kilometer per hour. 1 hour is there. So what is the V value? 300 minus 300 by 1 hour. Okay, 300 minus 300, 0. 0 by 1 hour. 0 by anything, 0. That's why acceleration is 0. So means simply what you can say is that when a race car is moving with a constant velocity, so there is no change in velocity. That's why acceleration is 0. For this one, what you can write, acceleration means the rate of change of velocity. That is the first point. What is the second one means? According to the statement, the car is moving with constant acceleration. Is nothing but there is no change in velocity. If velocity is not changes, automatically acceleration is 0. Is nothing but the race car is moving with 0 acceleration. So next one is an aeroplane is covered 1000 kilometer to 1005 kilometers in 10 seconds. Listen very carefully. Okay, an aeroplane is covered 1000 kilometer distance to 1005 kilometer distance in 10 seconds. Like this in other side. A skateboard is starting from 0 and covered the 5 kilometers in how much time? 1 second. Okay, now we can find which one has greater acceleration among aeroplane and skateboard. Listen very carefully. So aeroplane starting value means 1000. This is the initial distance. It is the final distance. Means 1000 to 1005 means the 5 kilometer distance covered by the aeroplane in how much time? 10 seconds. But the same 5 kilometers distance is covered by a skateboard in how much time? 1 second. Among the two, which has more acceleration? Acceleration means you know that rate of change of velocity. Is it correct or not? Velocity by time is called acceleration. That's why among the two, which one has greater acceleration? Means first one. What is the difference in distance? It is the d1, it is the d2. That's why d is equals to 1005 minus 1000, that is equals to 5 kilometers. What is the time? 10 seconds. That's why first you can find velocity is equals to displacement by time if they are going right. Okay, so 5 by 1, that is equals to 5 kilometer per second according to the statement. Here is also 0 to 5. 0 is the initial, 5 is the final. That's why 5 minus 0, 5. That's why d is equals to 5 kilometer. T is equals to 1 second. That's why velocity is equals to displacement by time. Then 5 by 1, that is equals to 5 kilometers in 1 second. Sorry, here in how many seconds? 10 seconds. 10. 5 1 5 2. That's why 1 by 2 kilometers per second, or that is equals to 0.5 kilometers per second. Sorry, that is equals to 0.5 kilometers per second. This is the velocity. Okay. Now, what is our acceleration? Okay. Or 1 by 2 only I can say that. Acceleration means velocity by time. Okay. What is the velocity of the aeroplane? Half kilometer. That's why a of A we have mentioned that is equals to velocity upon time. What is the velocity? 1 by 2 upon time. What is that one? 10. 5. It is brings to the negative side. That's why 1 upon 2 into 1 by 10, that is equals to 1 by 20. 1 by 20 means 0. 0.05 kilometer per second square for which one? Aeroplane acceleration. And skateboard acceleration of the skateboard is equals to velocity by time. Okay, so then what is the velocity? 5 kilometers per second. And what is the time? 1. That's why 5 kilometers per second square. So if you are observing that, what is the speed of the aeroplane? Okay, simply, okay, 0.05 kilometer per second square. What is the speed of acceleration of the skateboard? 5 kilometer per second square. That's why you are observing that, okay, skateboard acceleration is 5 kilometer per second square, and okay, aeroplane acceleration is 0.05 kilometer per second square. That's why, okay, so it says that skateboard has more acceleration than the aeroplane. Or simply, okay, same thing. Aeroplane distance is how much distance it travel? 5 kilometer. Aeroplane, here skateboard. Time is equals to 10 seconds. Next, under the skateboard, distance is, it will be travel 5 kilometers. Time is 1 second. That is, we know that. Okay. Now, how to find its acceleration? A is equals to velocity by time. Velocity is nothing but displacement by time upon time. Okay. That's why d by t square means simply we can write a is equals to v by t, that is equals to d upon t square. That's why what is the d value? 5. T square means 100. 10 range of 100. That's why. So what is the 5? Okay. That's why what we can write that? 0.05 means here 0.05 okay kilometer per second square. Next here a is equals to d by t square. What is the d value? 5. What is the t value? 1 square. 1 square means 1. That's why 5 kilometer per second square. This is the another mode. Okay, that's why it says that the acceleration of the aeroplane is 0.05 kilometer per second square and the skateboard is 5 kilometer per second square. That's why skateboard has more acceleration than the aeroplane. Means during this type of one, you first okay solve like this one. After that only with help of these two values we can write the final statement. Skateboard has more acceleration than the aeroplane. Next one. What is the deceleration of a vehicle moving in a straight line that changes its velocity from 100 kilometers per hour to a dead stop in 10 seconds? Listen very carefully. Okay, a car is moving with a deceleration. Means deceleration means here once again listen very carefully. Okay, based on the direction of acceleration. Okay, so based on the direction, acceleration can be classified into the two types. positive acceleration and negative acceleration. Means based on the change in the velocity. Sorry. Based on the change in velocity of a body, acceleration can be defined in the two ways. One is positive acceleration and second one negative acceleration or de-acceleration or retardation. So which acceleration we are called positive acceleration means the change in velocity of a body or velocity of a body is increases for every 1 second. Listen very carefully. Velocity of a body increases for every 1 second. That acceleration we are called positive acceleration. Next, if velocity of a body gradually decreases for every 1 second, that is called negative acceleration. Now here our concept is a car is moving with de-acceleration. Okay, in this one, de-acceleration means initially the body is having certain velocity, and de-acceleration means velocity is gradually decreases. Is nothing but finally comes to the rest. That's why in that our question. Okay, so a car is there. The car is moving with which one? De-acceleration. De-acceleration. What is the de-acceleration? So, but in the de-acceleration, what will be happen? 100 kilometers per hour to it will becomes to dead stop. Dead stop is nothing but 0 kilometer per hour. That is the dead stop means finally the body or car is comes to the rest position. That's why. So it is called initial speed. This is the final speed. Listen very carefully. It is the initial speed. Initial speed of the car before applying the brakes 100 kilometers per hour, and final dead stop means 0 kilometers per hour. Is nothing but 0. Then in how much time? 10 seconds. That's why t is equals to 10 seconds. Means is nothing but a car is moving with de-acceleration. Is nothing but negative acceleration or retardation. Is nothing but already a car is in the motion. Means it has certain velocity. That is the initial velocity. After applying the brakes, the speed of the car is gradually decreases, and finally the car is comes to the rest. That's why at the rest position means final velocity is 0 kilometers per second. Means so the car will come to the rest in how much time? 10 seconds of in the de-acceleration. What you can find here? What is the de-acceleration of the vehicle? Is moving in a straight line that changes velocity from 100 kilometers to dead stop. That's why you can find de-acceleration. A car, what is the de-acceleration of a car? When a car is moved with 100 kilometers per velocity, it comes to the dead stop in 10 seconds. That is one is there. But we know that the formula of either acceleration, that is either positive or negative, formula is same only. A is equals to V minus U by T. That's why. What is the V value? 0 minus. What is the U value? 100 kilometers. But here, listen very carefully. The time value they are given in the 10 seconds. But velocity is given in which one? 100 kilometers. That's why 100 you can convert it to the meters per second. That is, you know that 100 into 5 by 18 meter per second. So is nothing but 500 by 18 meter per second. That is one. That's why. So what you can write here? 500 upon 18 by. So t. What is the time? 10 seconds. So now let what you can write here. A is equals to minus of 500 by 80 by 10 by 1. 500 by 180. 0 get cancelled. So now here we come to that one. 50 into 80. 18 to 36. 4 1 0. 7 7 8 56 126. That's for here. 4 1 4 again 0. That's right. 7 7. So 50 by 18 is nothing but 2.77. Okay. Here what is the value? Is there minus? Sorry, minus. So means that is equal to minus 2.77 meter per second square, or is equals to minus of 2.8 meter per second square. This is the acceleration. So listen very carefully. So plus is nothing but positive acceleration, minus is nothing but negative acceleration. So what is the deceleration of a car when it is moved with 100 kilometers per hour and comes to the dead stop is nothing but comes to the rest in 10 seconds. That's why we know the formula of acceleration. Okay, this formula is suitable for either it is a positive or negative, whatever that may be. So A equals to V minus U upon T. Then V value is 0 and U value is 500 by 18. Okay, by 10. So minus of 500 by 18 by 10 minus of 500 by 180. 0 0 get cancelled. 50 by 180 means 2.77 means minus of 2.7. Minus is represented, velocity is decreases. Plus means velocity is increases. If velocity increases for every 1 second, that is called positive acceleration. Velocity is decreases every second, that is called negative or deceleration. That's why the deceleration of a car is 2.77 meters per second square is nearly equals to minus 2.8 meters per second square. And the last one is the thing I discussed. Correct your friend who says the acceleration gives the idea of how fast the position is changes. Listen very carefully. Okay. So means acceleration is nothing but the rate of change of velocity. That's why acceleration gives an idea of So how fast the body position is changes in a particular direction. That gives the acceleration. Listen very carefully. Okay, acceleration gives an idea of how fast or how fast the position of a body changes in a particular direction. That gives the acceleration concept. That's why. So simply you can write acceleration is given an idea of how fast the body position changes in a particular direction, or how fast the velocity of a body changes. That is called acceleration. Okay, so in the next video, in the motion chapter, I try to explain TQ questions. I hope every student thoroughly, carefully watch the videos which are uploaded by our school management in the YouTube. Okay, you must be watch or carefully watch the video 3 or 4 times every month. Okay, at the same time I said very clearly, so when after opening our school domain in the YouTube, you can tap the playlist option. Under the playlist, all the parts of the motion video only in a single file is there. If you can tap that one, so parts wise videos will be displayed on one side. That's why which part maybe you are missing. Okay, so that part you can easily see without searching of anything. That's why. So for your content, we can do in all modes at the same time. One more thing, will listen carefully. The first chapter is completed already. Okay, now we have discussed the TQ questions and the think and discuss also. In this video, think and discuss is also completed, but only TQ questions are there. Tomorrow onwards, in the next coming 2 videos, I try to explain TQ questions from the textbook. But so I hope every student will be carefully watch the videos which are uploaded by our management from the most motion chapter, and also you must be write the running notes after seeing the videos, because of after school reopen we check your running notebook. That is, quotes are keep in your mind and you watch the video 3 or 4 times, and after that so you can write the running notes.